If you want to choose the right tire for your car but don't understand tire markings well, in this video we'll help you figure out what tire parameters mean, what types there are, and which tire is the right fit for your vehicle. International tire markings provide crucial information about a tire's dimensions, load capacity, speed rating, and construction. These markings are essential for ensuring safe and proper tire usage on a vehicle. The metric tire code consists of a string of letters and numbers describing the dimensions of the tire. Before we explore the meaning behind tire markings, it's important to first understand the international organizations and standards that influence how tires are regulated globally. Organizations that influence national tire standards can be broadly divided into 4 categories: international organizations, regional organizations, government regulatory bodies, and industry associations. Before we dive deeper, let's briefly go over each of them to understand how they shape the tire regulations we rely on today. First, international organizations. ISO, International Organization for Standardization, develops global technical standards for many industries, including tires. ISO 4000 standards refer to a set of international standards that define tire size designations, dimensions, and load capacities for passenger car tires. It provides the global standard for how passenger car tires are sized and rated, ensuring safety, compatibility, and international consistency. Second, regional organizations. There are 4 core international and regional bodies most often referenced globally. They are European Tire and Rim Technical Organization, Tire and Rim Association, Japan Automobile Tire Manufacturers Association, Tire and Rim Association of Australia. Each of these 4 regional organizations significantly influences tire regulations, with manufacturers in their regions aligning closely with the standards they establish. While these 4 are the most prominent and internationally recognized, there are also other regional or national standardization bodies, such as those in Brazil, India, South Africa, and Russia, that regulate tires according to local requirements and conditions. These may adopt or adapt existing ISO, ECE, or regional standards, or create their own certification systems. Third, government regulatory bodies. Government regulatory bodies are official state-run organizations that enforce tire safety, quality, and labeling laws within their respective countries or regions. Unlike international or industry groups that develop technical standards, these bodies have the legal authority to mandate compliance with safety and environmental regulations, certify tires for road use through required markings, conduct inspections and issue recalls if safety risks are identified, coordinate with international organizations like UNECE to align national laws with global standards. These agencies ensure that all tires sold or used within their jurisdiction meet minimum performance, labeling, and safety requirements, protecting consumers and maintaining road safety. Here's 3 most influential government regulatory organizations: National Highway Traffic Safety Administration, United States; United Nations Economic Commission for Europe, China Compulsory Certification. While these are among the most influential and widely recognized government regulatory bodies for tire standards, there are also other national agencies that play similar roles at the local level. Fourth, industry associations. Industry associations are non-governmental organizations that represent tire manufacturers, retreaders, and other stakeholders in the tire industry. Examples of major industry associations are International Tire and Rubber Association and U.S. Tire Manufacturers Association. Industry associations support and guide the tire sector from within, helping ensure that tires are not only compliant with regulations but also safe, sustainable, and innovative. How they all interact. ISO provides the broad international baseline. Regional bodies adapt or add details to fit their local markets. Government bodies enforce the standards legally. Manufacturers must design tires that comply with the standards of each market where they sell. Breakdown of key markings. The metric tire code consists of a string of letters and numbers describing the dimensions of the tire as follows: an optional letter or letters indicating the intended use or vehicle class for the tire. If there is no letters, then it is a European metric tire. P, passenger car. LT, light truck. C, commercial trucks. ST, special trailer. T, temporary, restricted usage for space-saver spare wheels. A preceding P indicates that the tire loads are designed to TRA standards, while the absence of a letter indicates that the tire conforms to ETRTO standards. Tire size. The first number 225 indicates the tire's width in millimeters from sidewall to other. Following the slash, The next number in the sequence represents the tire's height as a percentage of its width, with 65 meaning the height is 65% of the width. We calculate this number by dividing the tire's section height by the tire's section width. So if a tire has an aspect ratio of 65, that means the tire's height is 65% of its width. You don't measure it on your own. Tire engineers determine it during design. They decide that for this tire, the sidewall height should be 65% of 225 millimeters. The lower the aspect ratio, the shorter the sidewall, more sporty or performance-oriented. The higher the aspect ratio, the taller the sidewall, more comfort and cushioning. Next in our series of tire markings is a letter instead of a number. The letter R indicates radial construction, which is the most common type for modern tires. Other examples are B for bias ply or D for diagonal construction. The last number 17 represents the diameter of the wheel rim in inches that the tire is designed to fit. Radial tires are the most common tires on the road today. They're called radial because the tire's internal ply cords are orientated in a radial direction, from one bead over to the other, at right angles to the direction of the tire's rotation. Load index and speed rating. Load index. A numerical code, for example, 91, indicates the maximum weight the tire can carry at the speed specified by the speed symbol. They are universal but slightly different in some regional standards. 91 equals 615 kilograms, 1,356 pounds, per tire. So for 4 tires, 615 times 4 equals 2,460 kilograms maximum vehicle load capacity. You can check any load index using a standard load index chart. Speed rating. A letter symbol, for instance, V, indicates the maximum safe speed the tire is rated for. V equals 240 kilometers per hour, 149 miles per hour. It reflects the tire's high-speed performance capability, typically for sporty or performance vehicles. This code is used in technical specifications, registration, and vehicle manuals. This is a standardized code that manufacturers use globally, especially in tire size markings. On some other tire, you can also see this kind of markings. These are practical, real-world usage limits printed on the tire for the user's reference. Max load, 1,300 pounds. Maximum weight that one tire can support when inflated properly. Max press, 35 pounds per square inch. Maximum safe air pressure the tire can be inflated to when cold. These are not coded and instead give immediate usable numbers for inflation and loading. DOT code. The DOT code can be found immediately after the letters DOT on a tire sidewall. It stands for the U.S. Department of Transportation. It is mandated by the U.S. Department of Transportation, but is used worldwide. It is useful in identifying tires subject to product recall or at end of life due to age, and indicates the tire meets U.S. federal safety standards. U2LL is the plant code and tire size code. U2 is manufacturing plant code, tells where the tire was made. U2, for example, is Goodyear Tires Manufacturer USA. LL is tire type or size code assigned by the manufacturer. For instance, the size code WC might correspond to the tire size 205/55R16. However, these size codes aren't standardized. Each tire manufacturer may assign these codes as they see fit, provided they maintain a consistent and explainable system within their coding. After the size code, the next sequence in a DOT number consists of 3 or 4 digits that designate the tire type. This coding, though optional, is widely used by tire manufacturers for internal tracking purposes, such as managing returns and quality control, tread design, construction, and other tire-specific features. The decision on how exactly to code the tire type lies with each manufacturer, leading to a variety of coding systems across the industry. The last 4 numbers of the DOT marking on tires tell you the week, 1 through 52, and year the tire was made. So, a tire with the last 4 digits of 5107 was made the 51st week of the year 2007, around mid-December 2007. Useful for tracking tire age, tires over 6 to 10 years old are often considered unsafe. M+S or M and S marking means mud and snow tire. Indicates basic all-season capability but not a guarantee of true winter performance. M+T or M&T stands for mud and terrain. Designed to perform in mud or on other terrain that requires additional traction such as on rocks, in deeper snow, and in loose gravel. 3PMSF means three-peak mountain snowflake. This symbol appears as a snowflake inside the outline of a three-peaked mountain. Often sits next to the mud and snow caption. This icon indicates they have been made with a special rubber compound that stays pliable in colder conditions, at or below 40 degrees Fahrenheit, giving them some grip on snow and ice-covered roads. While not every all-season tire is designed for severe winter driving conditions, this tire type's designation found on some all-terrain and all-weather options means you will have more grip than a standard all-season tire. So it is official winter tire certification, recognized in North America, Europe, Japan. Wear, traction, and temperature grades. These characteristics of passenger tires are displayed according to the Uniform Tire Quality Grading US standard only. Tread wear. How long the tire should last, compared to a baseline. The higher the number, the longer the tread is expected to last compared to a standard tire rated at 100. Traction. Wet surface braking ability. Rated AA, A, B, or C, it shows how well the tire stops on wet roads. AA is best, C is the lowest. Temperature, resistance to heat buildup. Rated A, B, or C shows the tire's ability to resist heat at high speeds. A is best, C is minimum acceptable. An E mark is a certification symbol found on tires that confirms the tire meets European safety and performance standards. All tires sold for road use in Europe after July 1997 must carry an E mark. It is required for all tires sold in most European countries and many others that adopt United Nations Economic Commission for Europe regulations. An uppercase E in a circle compliance with ECE Regulation 30. It's a United Nations standard that sets the rules for the design, performance, and labeling of passenger car tires to ensure safety and consistency across countries that follow UNECE regulations. A lowercase e in a rectangle, compliance with Directive 92/23 EEC. This is a European Union directive that was introduced in 1992 to regulate the types of tires that can be used on vehicles within the EU. The number inside the circle or rectangle identifies the approving country. The number outside indicates the specific type approval certificate for the tire. Other additional marks. Made in. Country of production. All-terrain. Designed to provide balanced performance on both paved roads and off-road surfaces like dirt, gravel, mud, and light snow. XL Extra Load, a tire that allows a higher inflation pressure than a standard load tire, which increases the tire's maximum load. Star, original tires for BMW. MO, original tires for Mercedes-Benz. Arrows, some tread designs are directional and designed to perform better when driven in a specific direction. Such tires will have an arrow showing which way the tire should rotate when the vehicle is moving forwards. Moreover, there's another important aspect to consider: the design of the tire's tread. Tires come in different structural patterns, sort of directional, symmetrical, and asymmetrical, and each of these has specific markings on the sidewall to guide proper installation. Understanding these tread types is essential for ensuring optimal performance, safety, and even tire longevity. 1. Directional tires or unidirectional. Tread pattern, V-shaped or arrow-like, designed to rotate in one direction only. Best for wet traction, high-speed performance, hydroplaning resistance. Must be mounted with a specific rotation arrow facing forward. If mounted incorrectly, performance and safety are compromised. Second, symmetrical tires. Tread pattern. Same across the whole tire. Can be mounted in any direction. Best for everyday driving, long life, low cost. Easier to rotate, for example, front to rear, without affecting performance. Not ideal for high performance or wet grip driving. Third, asymmetrical tires. Tread pattern. Different on inner and outer halves. Outer stiffer tread blocks for cornering. Inner, grooves for water dispersion. Best for sporty driving, wet and dry performance, modern vehicles. Marked with inside and outside, must be mounted accordingly. If flipped inside out, performance drops and tire may wear unevenly.